Hello and welcome to this lecture on C programming, variables, and constants. What is a variable? A variable inside of C is a name location in memory that contains a value that can be changed. What this means is that variables are readable and writable. So typically, variables have types associated with them. In this example on the left, you'll see that we have a variable named int myVariable. We are setting the value to that variable to 1, outputting it, setting a new value of 2, and outputting that value. And you can see the output of this program after it's been compiled on the right. Now, again, unpacking this, there's a few things that went on with these variables. First, we had a declaration, we had a variable value assignment, and then we had a reassignment. So as a side note too, again, that variables values are varying. In other words, they are both readable and writable. So a variable declaration, before a variable is even used, you need to declare it. So declaring this tells the computer to set aside some memory so that variable can exist. And C, variable declaration requires a type and a name. So in our example, we had the type integer we had a variable that was of type integer, and its name was myVariable. So the next part, which was the assignment of a value, happened right after the declaration. So we assign the value 1 to our variable named myVariable. After that, we just called our printf function with the formatted string as the first argument and myVariable as the second. So the reassignment happens after our first output. We then take the value 2 and reassign it to myVariable. So just to note again, this is the readable and writable functionality of a variable in action. Continuing on, we call the printf function with our formatted string, and again our first argument is the formatted string and the second argument is our variable. And last, per usual, we return our integer value of 0 from our main function. So you can actually compact the code for a variable declaration and an assignment into one line. So in this particular case, I declare our same variable name int myVariable, which is equal to 1 here. So instead of declaring and then setting a value, we can do it in one line. And we have been doing this in several other examples. We're just going ahead and being very specific about what is going on. And over here is our output of our program on the left. So let's go ahead and move on to constants. What's a constant? So like a variable, a constant is a placeholder for a named place in a memory location that contains a value, and it cannot be changed during the compilation process. That last part is the most important part. It means that a constant is read-only during the compilation process. So that guarantees no runtime read or write. So you can't, during runtime of your program, a constant value can actually be changed, which we'll get into in a second. So unpacking this program, we have a constant declaration and a constant value assignment. A reassignment will throw an error during the compilation process. So we'll see an example of that soon. The constant declaration and value assignment. So just like a variable, it requires a data type, a name, and a value to be assigned to it on the same line. So just like our one shot in declaring a variable and assigning it, we're just going to go ahead and use const. And const will typically be something like a postfix of the type. So in our example, we had int postfix with the word const followed by the variable name and the assignment of a value. So again, in C, this is a constant. This is a constant declaration, and it is only a compile time check. If you know what you're doing, you can actually force the value to be written too. So we're going to go ahead and show an example of that. So this is an example of a constant variable reassignment compilation error. So you can see here we have in const my variable, we print it out, and then we attempt to reassign it in our program later. And you can actually see my editor is telling me that there's an error already. And over to the right, we see when we try to compile using GCZ, that it actually throws a compilation error saying that it's a read-only variable. Now, the way that we're going to force this is by using something called pointers. And we haven't covered that topic yet, but we'll be at least showing an example of how to write into a const declaration. So don't be worried if you don't understand. We will cover that in a later topic. So this is how I can force a write. So you can see that we have our same variable. We're outputting that variable. Now, here I declare something new that you haven't seen. We have a pointer. This is what the star means, non-constant. This is equal to, and we haven't covered this yet, but this is the address of operator. So we're going in and saying, take the address of our my variable and then store it inside of the non-constant variable. Then what we do is something called a dereference operator. We go ahead and dereference it and store the value 5 at the memory address that was stored inside of non-constant, which happened to be pointing to our my variable. So we output that again, and we should see that a 5 is outputted on the screen. If we go ahead and run the program, you'll see that it is 1 and 5, which indicates that we did overwrite the value of that constant. So if you don't trust me, don't take my word for it. Go ahead and write this program and compile it, and you'll see for yourself. So just because I figured it would be useful to cover this right now, we will probably cover this again. But the address of operator. So we can get the address of a variable by simply putting a ampersand sign in front of a variable name. Now, this ampersand sign is used in other places like the bitwise and the logical or. But in this case, the way that we're using it is saying, give me the address of a particular variable. So as stated before, a variable is a name, location, and memory that contains a value. So we're just treating constants as variables when we manipulate them on the prior slide. Now in this example, you'll see that we have a variable x, we output it to the screen. We're going to go ahead and use our regular format string. The u is just unsigned, and we're just outputting our x. So you see it's 10, that's fine. Now we're going to go ahead and say the variable x memory location is here, and what I'm doing here is actually casting this. So I'm actually saying read this address of as something called a void pointer. You don't really have to worry about this yet. We'll get into this later as well. But you can see this here. This is called hexadecimal, which is also a topic we will be covering in the future. But this is a representation of the memory address of x. So some key takeaways. The variables are name locations that contain a particular type of data that allow to read and write operations. Constants are, again, named memory locations that contain a particular type of data that allow for read operations only during compilation process. It will check for writes, but you can force writes on this by using something called pointers. So at the end of the day, computers store things in binary, so type is nothing more than an indicator to the computer how to interpret data stored at a particular memory address. So we're going to go ahead and open up our code editor and start playing around with some of this stuff. Okay, let's go ahead and start working with some of the stuff that we learned about variables and constants to see exactly what is going on here. So first thing I'm going to do is print out the working directory to see where I am. Okay, we're in our directory that we've been working in this entire time. I'm going to go ahead and make a main.c file. Going to open it inside of the editor, and let's go ahead and just write our bare minimum code here. So int main, and go ahead and return our value 0. So the next thing we're going to do is declare some variables. So let's go ahead and make x, we'll make that 1. And why not make another y variable and say 0. So we'll save that. Let's print out both x, we'll say x %d and y %d. So x, y. And let's just go ahead and add a new line at the end of here. Let's just compile the code and run it to make sure that things are working. And there we go. So just like we've written before in other programs, we're outputting 2 variables this time on one line, and we're just go ahead and stating what the values are at this particular location. So now if we wanted to swap the values, we could do something like this. We could say, okay, well, let's make a temp value and call it x. Now we can take y, reassign it to the value of, let's actually make it y. Let's say x is equal to y, or it's equal to x, and x is equal to temp, right? Because we are going to, first, we're going to take the value of, let's go ahead and change these real quick. Let's say 5 and 1. So we're going to store the value 5 in this variable temp. We're going to then overwrite our value of 5 that was stored in y with the value of 1. And then we're going to go ahead and take the value that was stored in temp, and which should be 5, and then store it in x, effectively swapping the 2 values. So let's go ahead and compile. So you'll see that initially this was 1, and actually let's go ahead and do this. Let's print out some stuff here. We'll say prior to swap, after swap. So prior to swap, x was 1, y is 5, and after the swap, x is 5, y is 1. And you can see that we're not changing the order of the variables inside of our print statements, but we are indeed swapping the values by making another temp variable to store while we overwrite the other one. So this is an example of assigning and reassigning values and doing other things with variables. Great. So this should seem fairly familiar since we've already been doing some stuff like this. So we're going to go ahead and delete these lines. Now let's just go ahead and make a constant. Let's just make x, and we'll say const, and let's just output x. We'll do it this way. Okay, x. Now what we can do is clear our screen, gcc main.c .out, and as we expect, it's 1. Now what would happen is if I said x equals 20. Let's see what would happen by trying to compile, and we'll see that the assignment of a read only variable is happening right here. It's basically yelling at me, telling me I cannot do this. Now we could keep messing around with this and force it to write like we saw in the example slides, but there's no need to go that far. So this is basically just some really brief examples of how const and variable assignment stuff works. So the other thing I wanted to show you is, let's go ahead and just make a variable x. We're going to go ahead and say x value, and then we'll say x address. Now the P indicates something called a void pointer, or it will print out a hexadecimal, which is the weird values that you saw that kind of look like, 0x AF blah blah blah, like this stuff, and it had numbers in there as well. We'll go over hexadecimal at a later time, but it represents a number, and I'll just go ahead and show you. I'm actually not going to put the cast in. The cast is going to be compiler dependent. Some people will yell at you and tell you have to do it, but we'll see that it isn't actually required in this instance. But yeah, so here's the hexadecimal value. Let's go ahead and let's try this. Let's output a unsigned number. Now this will give us probably some weird big number, right? Yeah. So you can mess with the formatters. If you don't really remember what the formatters are, you can always go to man3 of printf and scroll down a bit, and you'll see a large list of things that you can do. Here is P. You see it says the void star pointer argument is printed in hexadecimal. There's other things that you can use. We just use the U one. U is up here. Let's see, and you could probably find it in here, an unsigned decimal. Yep. You can use an X for an unsigned hex number. There's a bunch of different things you can do. So you can also take this time to mess around with that if you want to get a better understanding of how to use that stuff. But definitely write down these examples just so that way you can get a clear picture in your head of what's going on. Great. See you in the next lecture.